This is the exponent section. So these are the rules that y'all seeing right here. And each time I go through a rule, I'm gonna try to give y'all an example. Like this first rule, you got a to the power of n times a to the power of m. And so whenever the bases are the same, the bases is the a and the a. Then all you do is add the top part. So the answer is gonna be a to the power of n plus m. You just add the two top parts up. And so if you have like 3 to the third power times 3 to the second power, the answer is going to be 3 to the fifth power. You just add the top part up. So the 3, you don't do nothing with the 3. It's still going to just be 1 3, but you add the top parts up. So all of this is exponent. Any questions on that one? Okay. Yeah, when the bases are the same. This next one, you got a to the power of n divided by a to the power of m. Just like when you multiply the first one, you add. This other one, when you divide, you subtract. So what you're going to end up with is you're going to end up with an a to the power of n minus m. So the top power goes first, and the bottom power always goes second. So it's going to be n minus m. And that's the rule on that one. So if you had, for example, 3 to the sixth power divided by 3 to the third power, then what the rule is going to be, you're going to have 3 to the power of 6 minus 3, which is just 3 to the third. Everybody got that one? Okay. The next rule, you got a to the power of n, and then it was raised to the power of m. So this was raised to a power twice. They say if you raise it to a power twice like that, the rule says to multiply. And so you're going to have a to the power of n times m. Or you can just call it nm if you want. And so an example is like 3 to the power of 3, and then you raise it to the power of 4. And so all you do here is you're just going to have a 3, and then 3 times 4, which is 12. So the answer is going to be 3 to the power of 12. Questions on that one? Okay. What'd you say, go slower? Okay. Next one is a to the power of negative m. Now, you're never supposed to have a negative exponent. So if ever you have a negative exponent, they say you're supposed to flip it. And you know everything can be written over 1, so you can write this as a to the power of minus n over 1. Just the exponent over the number 1. So if you got a negative exponent, you flip everything. So it's going to be a 1 at the top, and then it's going to be a to the power of positive n at the bottom. Everything got flipped to the other side of the fraction. So for example, if you got 3 to the power of negative 9, you can't say that that's the answer. So if you had that as an answer, it'll be counted wrong because you're not supposed to have a negative exponent. So the way you handle it is you flip the whole thing, so it becomes 1 over 3 to the power of positive 9. And now the 9 is positive. If everything is positive, then you can turn it in and say that that's the answer right there. You can't say 3 to the negative 9 is the answer. Same thing for 1 over a to the minus n. This one, the negative exponent is at the bottom on the denominator. So that's fine. All you do is flip it to the top. You always flip it to the other side. So this is going to become an a to the power of positive n. You can write over 1, or you can just say a to the power of positive n if you want. So an example is if you got 1 over 3 to the negative 9, then you bring that to the top and it becomes 3 to the power of 9 over 1. Any questions on that one? Y'all good with that one? Okay, the next one, this one here, this is self-explanatory. If you got anything to the 0 power, it's going to be equal to 1. No matter what it is. It can even be a shape. So if we had like triangle, well, a drunk triangle to the 0 power, then that's just going to be 1. If you had the number 1000 to the 0 power, it's still 1. So that's what that is. On this last one, you got a times b on the inside of the parentheses with an n on the outside. Now, what are the powers of the numbers on the inside? 1. That's something you need to always know. And so the n on the outside, it gets multiplied times the powers and not the actual letters a, b. So what you're going to have is you're going to have a to the n times b to the n. And that's what that one is. So let me try to clear this. Actually, hold on one second. Pause. Okay, so to go over some examples, let me start off light. So the first example, let's say if I have negative 3 to the 0 power. So negative 3 to the 0 is going to be a negative 1. Let me tell you why. If you have a negative 3 in parentheses to the 0, then that's equal to positive 1. But whenever you have a negative and it's not in parentheses, that 0 only applies to the numbers on top of. So if you had, for example, a negative 9 to the 0, that's like a negative 1 times 9 to the 0. And 9 to the 0 is 1, but you still got that negative 1 sitting out there. So that's like negative 1 times 1. And that's why the answer is negative 1. But if you have a negative 9 in parentheses to the 0, it's still saying that you got a negative 1 times 9. But all of it's in parentheses. And you remember that rule that we had, if you have something with a power on the outside of parentheses, what's the power of the negative 1? And the power of the 9 is 1. So we got a negative 1 to the 0 times a 1 to the 0. Now both of them got a 0 power on it. And so therefore they both 1. So you got 1 times 1, which the answer is going to be 1 on that one. So that's is you have let me give you a problem that got a lot of pieces in it. You got 25 a to the 13th power, b to the 4th, and all of that is divided by a negative 5 a to the 2nd and a b to the 3rd. And they want you to simplify this. So first thing you do is you can handle the numbers as you see them. So the 25 and the negative 5, you can just treat that as a regular fraction with numbers. And so if you reduce that, what would you get? You get negative 5. That's the 25 divided by negative 5 will give you negative 5. And if you want to put it in the form of a fraction, you can call it negative 5 over 1. Because the negative 5 will be at the top. And so now you got a to the 13th divided by a to the 2nd. A to the 11 because the rule said to do what? Subtract. So you're going to have a to the 11th over 1. And what about b to the 4th over b to the 3rd? That's just b. Or b to the 1 if you want to call it that. And that's over 1. And so the ones at the bottom, since there's only ones at the bottom, you don't have to write them. And so the answer would just be the negative 5 a to the 11th and b to the 1st power, or just b if you want. So